Hello everyone, my name is Lim Wei Chen. I'm here to talk more about my FYP project, fuzzing Linux binary with AFL++. So, how sure are you that the software you use is fully secure? With that, let's have a quick run through for introduction. So, software vulnerability is a major factor for many cyber attacks in the recent years. So, the consequences of attacker exploiting the software vulnerability is that he or she can access sensitive data, utilizing your smartphone device, turning on your camera, or maybe turning on your mic without your permission. Next, not all software developers are security trained, so finding vulnerabilities are not their top priority, and then a security researcher like me will come in and submit our bug report to tell them how serious the vulnerability that will affect the users. Next will be understanding of fuzzing. So the key idea is to trigger software crashes by inputting some random input files, which are also known as seeds. So the tools that we use to do fuzzing are known as fuzzers. We'll apply mutations to these input seeds to generate new test cases when it execute towards the target program. And the crashes may indicate newly discovered vulnerabilities or performance issues. So this is a quick flowchart to understand how it works behind the scene. So from the start, you input with input seeds, then you use as a test case to do a program execution on it. Does it have violations? If yes, a new bug was discovered. If not, they will went through another test case generation where it applies the mutations, for example, bit flipping or inserting or deleting data, swapping data, and such. And then rerun the program execution and then check the violations. So the problem with software bug finding and auditing. Conventional testing methods are usually very high time costs, which can last up to months if the code base is very big. And for fuzzing wise, within hours to days, we are able to get results on a 0-day vulnerability. And also it's very high monetary cost. So it can ranges from hundreds to thousands depending on the person you hire to audit your code, and also how big is your code. Yes, so for fuzzing is open source, so anyone can just do it for free. Next will be it's not automated, so conventional methods are usually require human intervention. Someone must be there to sit down, going through line by line, and then to catch the bug accordingly. Then lastly, you need prior knowledge of the software, because without the knowledge you won't know where to start. So to create test cases, to do the manual auditing, you also need the background knowledge. So for me as a beginner, I'm able to come in to start fuzzing without any prior knowledge. So project objective: to demonstrate the application of fuzzing with AFL++. Then, in hopes to discover 0-day vulnerability of Linux program. Lastly, will be work with the developers to mitigate the found vulnerability through bug reports and replication of the vulnerability crashes. So the equipment and VM used, there will be the Aftershock laptop with Windows 11. Then for the VM will be on the VMware Workstation Pro 16, 4 cores for processor and 8 gigs for RAM. So next will be the setting up of fuzzing environment. So we must learn to set up our AFL++ environment properly, where you include all the necessary libraries, correct steps on GitHub, follow thoroughly. And also the target program, usually source codes are available where you're able to compile the binary on your own to inject AFL code so that you can start the fuzzing process. At the same time, you must make sure the environment you are working in contains all the necessary dependencies that the target program may use. Then next, after the compiling of the target program, will be to ensure AFL and ASAN is being injected into target program. And lastly, will be the preparing of the fuzzing seeds. So fuzzing seeds can be prepared by gathering from multiple sources on GitHub, or maybe the past proof of concept files, POC files, from the old vulnerability found. And then next will be to optimize the seeds. So to start optimizing the seeds, right? So you must use the AFL cmin to remove redundant seeds or repeated seeds. So this is how you reduce the overall seeds corpus size, and then followed by the AFL tmin So AFLT mean is to look for redundant data within one seeds and then remove one at a time from one seeds, so that the seeds itself can be a smaller size to improve fuzzing speed. Next will be to understand the AFL++ status screen. Three things to focus here are the safe crashes, and also the run time and the map density. So for the safe crashes, right, it's good to have more, so you can able to investigate more crashes, and maybe more different vulnerabilities may show up. So be careful that after 1 week of fuzzing, you can end up with 0 crashes, which it could be the fuzzing environment is not set up correctly, or the seeds you use are not very good, are shallow. Next will be the runtime. As I mentioned before, it could last from hours to days. So from here it's 2 days and 4 hours, we are able to produce some results. Then as for the map density, as shown here is 18%, so it could be higher. So the highest I will show in the later slide. Okay, you can go up to 75% as such. The higher will be better, so you're able to reach some hidden codes within the target program, and then to discover more hidden bugs. Fuzzing. So to craft fuzzing commands, usually you will use the command line, for example mp4 box. So you display info of an existing mp4 file by doing this -info. So example, this kind of command you're able to have like 20 to 30% code coverage of the entire code base, so it's good to start from there. Next will be the parallel fuzzing. So parallel fuzzing allows you to utilize multiple core assigned to the VM, and each core will allocate one task with 100% usage, so this will fasten the fuzzing process. Then you must take note that crashes found can also be false positive, so the 97 crashes as found in the previous slide could also be 0 in the end. So this is a very ideal fuzzing result, that after like 1 day with good quality seeds, you are able to produce up to 72% of map density with over 700 crashes in total. So to triage the found crashes, so these are the things that you can replicate the crashes. So the POC files for each crashes will be generated by AFL. Then you can use it and run the same command with the input POC. Then you replicate the full crash. So from here is the Asan's report. Then this report will show you that what is the vulnerability that exists within this target program. So we can see that from the function gf, odf, vvc, cfg, readbs is the first function that encounters this vulnerability and crashes. So next will be the submitting of bug report. It's good to test the POC again on the latest version of the target program, because fuzzing might take some time. Then by the time you go and test again, developer must have fixed the bug. So it's good to try out the POC file again, see if it replicates on the latest version. So next will be learn to craft bug report accurately. So there are bug reports on like websites where it's disregard because file do not have like the report do not have POC files, or given incorrect CVSS score, which is the Common Vulnerability Scoring System. So these three things are like the meta things to provide when you're submitting a bug report. And lastly is to be patient, because developer might take time to come back to you due to different time zone or their own commitments. Next will be the one example of my bug report. So things to include, there are a lot, like the header, the description, what kind of version of the target program, and followed by the POC, which is the Asan fully generated report. Yeah. And next, if your report is successful, the developer will know to validate the report and award you a CVAE. So this CVSS score is submitted to NIST for evaluation and also the confirmation of score. So picture on the left shows that throughout the whole FYP, I'm able to get 2 CVEs confirmed. Then on the right is the score that confirmed by the NIST that the scoring given by me has been approved, and they are matching the score with me at the bottom. CNA is supported by me, then NIST is by them. And then recommendation I have for this FYP. So fuzzing is not all Swiss Army knife to all software security problems. So usually you pair with the conventional methods where you able to catch bugs that are not obvious to the human's eyes. So fuzzing can help you to do that. So more computing resources to speed up the fuzzing process will be more on the CPU core, able to take up more parallel fuzzing by assigning more cores, and also with higher RAM in memory. So this will not crash your fuzzing task halfway when you are like due to limited memory resources. And also to start early, due to you have uncontrollable time costs for one fuzzing campaign, usually can at least take from days to 1 week. And lastly, this is the ideal fuzzing result that we wish everyone can able to replicate. With that, thank you very much. I finished my presentation.